Have you ever wondered what a lighthouse would look like in space? Well, the universe, in its whimsical and grandiose fashion, has already cooked up an answer for us. Meet the Pulsar stars, our very own cosmic lighthouses. Pulsar stars are celestial objects that emit beams of radiation out into the cosmos. Much like the steady beam of a lighthouse piercing the foggy night, these pulsars send out regular pulses of light that cut through the vast, dark expanse of space. These aren't your average twinkling stars. Pulsars are unique. They are the remnants of massive stars that have gone supernova, leaving behind a dense core that spins at an incredible speed. The analogy between pulsars and lighthouses goes beyond their shared trait of emitting light. There's a rhythm to their radiations, a predictable pattern that we can observe and measure. It's as if each pulsar is tapping out a message in a cosmic Morse code, a rhythmic beacon that is distinctly its own. This rhythmic pulsing is not random. It's the result of a pulsar's rapid rotation and intense magnetic field. These forces combine to create a beam of radiation that sweeps across the cosmos like the beam of a lighthouse. And thanks to their incredible consistency, we can use these pulses to make precise measurements of time and space. But why are we so fascinated by these cosmic lighthouses? Perhaps it's their unwavering reliability in the midst of the cosmic chaos. Or maybe it's the enigmatic nature of their existence, born from stellar explosions and spinning in the dark corners of the universe. These pulsars, with their rhythmic pulses, serve as guiding lights, reminding us of the incredible phenomena that the cosmos has to offer. So the next time you see a lighthouse, casting its steadfast beam into the night, think of the pulsars. These cosmic lighthouses, with their predictable pulses, echo the same sense of mystery and wonder. They are a testament to the universe's capacity for awe and surprise. So next time you think of a lighthouse, remember, the universe has its own version. Did you know that the discovery of pulsar stars was quite a cosmic accident? It all started in the late 60s, when a young woman named Jocelyn Bell Burnell was working on her doctoral thesis at the University of Cambridge. She was part of a team building a radio telescope to study quasars, which are incredibly distant and bright galactic nuclei. While poring over the data, Bell Burnell noticed something peculiar. There were regular pulses of radio waves that didn't match the patterns of any known celestial object. These signals were so regular they almost seemed artificial, leading to the initial nickname LGM, or Little Green Men, as some in the scientific community humorously speculated that they might be signals from an alien civilization. As the intrigue grew, the team dedicated more time and resources to these strange signals. After eliminating all terrestrial sources and potential errors in the equipment, the signals continued to pulse with astonishing regularity. The precise nature of these pulses suggested a celestial source of a highly disciplined order, something not typically associated with the chaotic cosmos. Eventually, it was determined that these were not signals from extraterrestrial beings, but from a new type of celestial object, a rapidly spinning neutron star, now known as a pulsar. Neutron stars are the remnants of massive stars that have gone supernova, and their incredibly dense core remains, spinning at an astonishing rate and emitting beams of radiation. These beams sweep across the universe, just like the light from a lighthouse, and when they intersect with Earth, we can pick them up as regular pulses of radio waves. Thus, the mystery of the Little Green Men signals was finally solved, and a new and fascinating celestial object was discovered. So, from a humble radio telescope in Cambridge to the detection of a new type of star in the far reaches of our universe, the discovery of pulsars was quite the cosmic adventure. Pulsars have since been found throughout our galaxy and beyond, their regular pulses serving as cosmic lighthouses in the dark expanse of space. From an alien signal to a celestial find, that's quite a journey, isn't it? What if I told you that stars can have a heartbeat too? Now, before you start envisioning stars with tiny stethoscopes pressed to their chests, let's clarify. No, stars don't have actual hearts, but some of them do have something quite similar, a pulsating rhythm that is as regular and predictable as a heartbeat. This rhythm is found in a unique type of star known as a pulsar. These stars, which are actually the remnants of supernovae, emit beams of electromagnetic radiation out into space. These beams are so powerful and so regular that they can be detected from Earth. The frequency of these pulses varies, but some pulsar stars pulse hundreds of times per second. It's a bit like the universe's own version of a disco ball, if you will. But instead of reflecting light, these pulsars are shooting out beams of intense radiation. And this, my friends, is where things get really interesting. You see, these pulses aren't just random bursts of energy. They're actually the result of the pulsar's rotation. As the star spins, its magnetic field lines twist and turn, creating a sort of cosmic lighthouse that sends out these regular pulses of energy. But wait, there's more. These pulses are so regular, so predictable that they can be used to measure time. In fact, they're so precise that they rival the accuracy of atomic clocks here on Earth. So you see, pulsars aren't just stars. They're cosmic timekeepers, sending out their regular pulses like the steady beat of a heart. Each pulse, each rotation, is a testament to the incredible forces at work in our universe. So the next time you look up at the night sky, remember the pulsar. Remember its steady, rhythmic pulses, its cosmic heartbeat echoing across the vast expanse of space. So, in a way, we can hear the heartbeat of the universe through these stars. Every star has a story, and pulsars have quite a spectacular one. Imagine, if you will, a star much like our own sun, but many times larger. This massive star lives a vibrant life, burning brightly and fiercely for millions of years. But even stars, with their fiery hearts and radiant bodies, cannot escape the inevitable end. When such a giant exhausts its nuclear fuel, it collapses under its own gravity, triggering a supernova explosion. This explosion is so powerful, so cataclysmic that it can briefly outshine an entire galaxy. But what remains after this stellar spectacle? A core, a heart of the original star left behind. This is no ordinary heart, mind you. It's incredibly dense, so dense that a teaspoon of its material would weigh as much as a mountain. This is the birth of a pulsar. Now, this pulsar doesn't just sit idly in the cosmos. No, it spins. It spins incredibly fast, up to several hundred times per second. Imagine spinning a top and watching it whirl around at a breakneck pace. That's nothing compared to a pulsar. These celestial tops keep spinning, emitting beams of electromagnetic radiation from their magnetic poles. These beams sweep across the cosmos like the beacon of a lighthouse, only visible when pointed directly at us. And with each sweep we receive a pulse of light, hence the name pulsar. But why does a pulsar spin so quickly, you may ask? Well, it's all thanks to the conservation of angular momentum. Picture an ice skater pulling in her arms during a spin, causing her to twirl faster. Similarly, when the star collapses, its rotation speed increases dramatically, turning it into a cosmic spinning top. So there you have it, the life cycle of a pulsar star, born from the remnants of a massive star, surviving a cataclysmic explosion, and living on as a rapidly spinning, incredibly dense cosmic beacon. From a fiery birth to a pulsating existence, pulsar stars truly live a stellar life. Who needs a wristwatch when you have a pulsar? Now, I know what you're thinking. How can a star, light years away, possibly help us keep time? Well, as it turns out, pulsars are not just any stars. They are extraordinary cosmic timekeepers. Imagine a clock. Now make it 1,000 times more precise. That's a pulsar for you. These rapidly spinning neutron stars emit beams of electromagnetic radiation out into space. As the star spins, these beams sweep across the cosmos like the hands of a clock. And here's the kicker, these pulses are incredibly regular. So regular, in fact, that they rival the precision of atomic clocks on Earth. This regularity allows pulsars to serve as cosmic clocks. Astronomers use these celestial timekeepers to study the very fabric of the universe. By observing the timing of these pulses, they can test theories of gravity, study the interstellar medium, and even detect gravitational waves. Think about it. These cosmic clocks are helping us unravel the mysteries of space-time itself. They are providing us with a tool to test the fundamental laws of physics, to probe the universe in ways we never thought possible. And here's a fun fact to tickle your brain. Some pulsars spin so regularly that if they were as big as a city, the variation in their spin rate would be slower than the speed of a tortoise. That's right, a tortoise. So pulsars are not just celestial lighthouses, guiding us through the cosmos. They are also cosmic metronomes, ticking away with incredible precision. They help us understand the universe in its grand scale and remind us of the beauty and complexity of the cosmos. So, pulsars not only light up the cosmos but also keep time for the universe.